Hey guys, welcome to lesson 21 here in module 5. We are going to continue using a number line to compare the size of fractions. And this time we're going to be looking at things called equivalent fractions. So the word equivalent is a longer word, just meaning equal. So we're going to look at fractions with different numerators and denominators that are actually equal to each other. So a basic example of that would be, the most basic example of that would be something like 2 halves and 4/4. Those both equal 1. So they look different, but they both equal the same thing. We also could think of a fraction like using similar ones there. 1/2 and 2/4 are the same thing. So if I said you could have 1/2 of a cookie or you could have 2/4, that would mean the same exact thing. You get the same exact pieces, assuming you're working with the same whole. And since we're working on a number line and we're working with the unit of 1, we are working with the same whole. So let's take a look at how we can go about comparing these two things. Not two things, but how we can compare two things on a number line. So you'll see here, it took me a minute when my brain doesn't work the same way that this has been prepared. So I understand how sometimes you guys might get something and look at it and be like, this isn't how my brain sort of understands this topic. So I'm with you there because my brain didn't think the same way that they do when they designed the sheet. So let me help you understand it like I had to understand it. On the top, they are measuring in halves, and on the bottom, they're measuring in fourths. And these lines that are dotted are fourths, are only fourths. The lines that are fully drawn in are both halves and fourths. Those ones are going to be the equivalent fractions. Those are the equal fractions. And we go from 0 to 2 here. So let's label the halves first. So at 0, I'd have 0 halves, right? This is not a half. I'm not halfway through 0 to 1 there. So I have 1/2, and then 1 equals 2 halves. And then this is 3 halves, and that's 4 halves. Okay. Notice that like between 1 and 2, the halfway point's right there. These dotted lines, those have nothing to do with halves. On the bottom, I have 0/4, and then this dotted line is 1/4, 2/4 goes here, 3/4 on the dotted line. As I mentioned in my initial example, 4/4 is equal to 2 halves, 5/4, 6/4, 7/4, and 8/4. Again, we can check that by 2 times the denominator is 8. And we can check the 4 halves if we wanted to by saying 2 times 2 is 4. So we know that those are both accurate. So now that we have that filled in, we can sort of take a look at this and understand that, for example, I'll circle all the similar ones: 0 halves and 0/4, 1/2 and 2/4, 2 halves and 4/4 is equal to 1. So all 3 of those things are equivalent. 3 halves and 6/4 are equal, and 4 halves, 8/4, and 2 wholes are all equal as well. So anything that's circled there, we could consider those, or we do consider those equivalent fractions. So I'm going to skip to the bottom here for a second, and it says to color fractions equal to 1/2 blue. So that would be, I'm going to box them in blue. Those are both 1/2. Fractions equal to 1 in yellow. So 2 halves and 4/4 are both yellow. Oh, that didn't show up great on the screen there. Anything equal to 3 halves is green. So 3 halves and 6/4 are green, and anything equal to 2 is red. Ooh, that marker's running out of ink there. And so again, that sort of went through the same process that I just did in circling it, just in a more colorful way. And we were able to show equivalency there as well. So let's do this second example, and then we'll go through the same process of coloring in equivalent fractions. Again, that word equivalent, you're going to hear me say it all the time, and I'll explain it to you a bunch of times, but it just means equal, same size. And we can go back to our last lesson that we did, and we can think about equal being the same distance from 0. So 1/2 and 2/4 are both the same distance from 0, so they're equal to each other. They look different, but they're equal to each other. They look different like in numerator and denominator wise. Size wise, they're the same. So let's do halves again. We have 0 halves, 1 half, 2 halves, which we know equals 1, 3 halves, and 4 halves. Again, we took each whole and we split it in half. Each whole, split it in half. Now we're going to do 6 on the bottom. They've already started 0, 6, and they've already marked them off for us. We just have to fill it in. 1, 6. I don't like how they did this. I'm going to label it under where they actually are. 2, 6, 3, 6, 4, 6. Oh, sorry, 3, 6 goes here. 4, 6. There aren't nearly enough lines on this bottom one. 5, 6, 6, 6, 7, 6, 8, 6, 9, 6. Remember when I said that my brain doesn't work the same way that I set this up? To me, like they should have had a line for each of these so we could easily see where they all go. 10, 6, 11, 6, and 12, 6. Okay, so now we're going to go through and we are going to match up anything that's equal to each other. We'll start with the red this time. So fractions equal to 2. So I have 4 halves and 12, 6 are both equal to. Notice that 2 times 6 is 12, just like 2 times 2 is 4. That's how we tell that those things are the same. Anything equal to 3 halves is green. So in that case, these two things both share the same marking. They're the same distance from 0 on my number line, which means they're equivalent. They're the same size. Anything equal to 1 is in yellow. Well, that's a straightforward one that we've worked on a lot this year. So we have 6, 6, and 2 halves. Both have matching numerators and denominators within their fractions. So that means that they are equal to each other. And lastly, in blue, we have 1 half. So that one's simple with 1 half. And then 3 out of 6, again, you can think about if I had, let's do this example. It's easier for me to draw. If I had 3 out of 6 pieces of something, I would have had half of it. So that visual sometimes helps you understand what it is to be a half. So now that we've done all that work, we could say 2/4 is equal to how many sixths? Well, 1 half was equal to 2/4, right? So if 1 half is equal to 2/4, we need to find out where it is on the sixth number line, which is 3, 6. 1 half is the same as 2/4, which is the same as 3, 6. They didn't put that half in there, but that's sort of the common thing between these two number lines, right? They both have halves on there, halves and halves. So I found out what 2/4 was. It was 1 half, and then I took that 1 half and found it on this number line, saw what it matched up with. Multi-step process there. 6, 6, that's 1. So that's 2 halves, which is the same as 4/4. We know that one's a straightforward one. We've talked about that like 1,000 times this year. And that anytime we have the same numerator and denominator within a fraction, that means we have 1 whole. And then the last one is 3 halves. So I'm going to go find 3 halves on my number line. 3 halves is the same as 9 sixths. So I can put my 9 in there. And then I could take 3 halves and say, oop, that's the same as 6/4. So I look and I say 3 halves, and I find that 6. And then what I need to fill out down on the bottom here is the 4ths portion of that. So this is the process of going through this is probably more complicated than actually understanding it. Like going from one number line to the other and using multiple number lines at the same time can be a little bit tricky. But hopefully you can understand that, like, if this is equal to this, then this is also equal to this, that sort of thing. If A equals B and A equals C, then B equals C. That's sort of the math thinking behind that. This problem basically says that Jack and Jill are both measuring rain. Jack is doing it in 1/4 of an inches, and Jill is doing it in 1/8 of an inches. So let's draw a number line from 0 to 1. I'll measure in fourths first. Okay, 1/4, 2/4, 3/4. This would be 4/4. That would be 0/4. I'll just put those in, which is 1, which is 0. Okay, then up here I'm gonna do eighths. Well, we know the eighths are half as big as fourths because 4 times 2 is 8. So we can just split each of our sections in 2 parts and then label 0/8, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. And now I need to compare. Jack had 2/4 of an inch of rain, which is, well, we'll get there in a minute. But he has to compare that to what Jill got, and Jill got the same amount. So what did Jill get? Well, Jill got 4/8, right? If they got the same amount, that means they're the same distance from 0. They measured in different things. They have different markings on their measuring tools, but they're the same distance from 0. They collected the same amount of water. So they are, these are equivalent fractions. So 2/4 is equal to 4/8. Now it says down here that they have a younger brother who is measuring in halves. And so is he right? Why or why not? That they used a 1/2 inch, or they got a 1/2 inch. So I can draw a number line for that. I could put fourths on it again. I'm gonna do this kind of quickly. And I'm just gonna say that 2/4 equals 4/8 on here because we determined that in the last part of the problem. And then I'm also gonna mark 1/2 on here, 0 and 1. Is 1/2 the same as 2/4 and 4/8? You bet it is. Those are all the same as each other. I'll go a little bit above and beyond here for you and explain sort of why this is true. If I have 1/2, to change that into a different fraction, I can't change just one portion. I have to change the top and the bottom the same. So if I multiply the top by 2, I have to multiply the bottom by 2. So if I do that, 1 times 2 is 2, 2 times 2 is 4. That's how you get another equivalent fraction. Now, if I want to change that again, I can multiply the top by 2, but if I do that, I have to multiply the bottom by 2. The reason that's true is 2/2 is 1. So multiplying by 1, we know that keeps the same number. So I've really just multiplied by 1 here, but I'm just changing what the numerator and denominator are. That equals 4/8. I could go further. I could multiply that by 10 and this by 10 if I wanted to, and get 40/80. So that's sort of how it works. We'll talk a little bit more about that in class, but that's how you can always double check too. If you do in fact have 2 equivalent fractions, is especially in this case, like we're working with halves, fourths, and eighths, multiply the numerator and denominator by the same thing and see what it comes out to. All right, guys, a lot of complicated stuff has come your way in math here recently. I appreciate all the hard work and understand that it does take time. The beginning of this unit sort of goes kind of quickly when we're looking at pictorial models, and we're kind of easily able to understand that visually and see how things work. Once we get into this more conceptual stuff with number lines and distance from 0 and equivalent fractions, I understand that the progress slows down a little bit. Sometimes the level of frustration goes up a little bit. And I'm here to support you guys, so please let me know what questions you have so I can help you out.